This is video lecture number 4 for chapter 12. We're going to finish the chapter today. So let's look at phase changes. The first phase change is melting. When a solid absorbs energy, the energy will disrupt the intermolecular forces of attraction, holding the solid together, and the solid will then change into a liquid. When a solid absorbs energy, it is called the absorption of energy endothermic. Energy has to enter in order for the solid to melt. So we have to know endothermic means absorbing energy. Vaporization is when a liquid absorbs energy. The energy will disrupt the IFAs holding the liquid together. So vaporization is evaporation, is when the liquid changes to a gas at the surface of a liquid, and boiling is vaporization when the liquid changes to a gas inside the body of the liquid. This is also endothermic because it absorbs energy. Freezing is when a liquid releases energy. Now the IFAs are strong enough to crystallize the substance back together. Since it releases energy, it is called exothermic. Energy exits or leaves. Condensation is when a gas or a vapor releases energy. Now the IFAs are strong enough to condense the substance to turn it back into a liquid. So this is exothermic. Sublimation is the phase change when a solid absorbs energy, endothermic, but passes directly to the gas phase. Since it's absorbing energy, it is endothermic. We're going to see that there is no change in temperature during a phase change. When something melts, the temperature of the ice stays at 0 degrees Celsius. Now the last term is a little bit more confusing, and it's vapor pressure. Vapor is a gas, pressure is the force of the gas. The conversion of a liquid to a gas is called vaporization. If it occurs at the surface of a liquid that's not boiling, we simply call it evaporation. A liquid evaporates faster when it's heated because the added heat increases the average kinetic energy of the liquid's particles, enabling more of the particles to overcome the attractive forces, the IFAs, which keeps them in the liquid state. But if we're in a closed container, no particle can escape to the outside air. So the vaporized particles collide with the walls of the sealed container, increasing the pressure inside of the sealed container, and produces a vapor pressure, or a force due to the gas above the liquid. But this only occurs if the container is closed. So if you close the container and you heat it up, the evaporation process increases, more gas particles are put into the container, and the pressure increases. So in an open container, the particles just leave, so there is no increase in pressure. In a closed container, the particles will go into the air, the space above the flask. But what's also interesting is that as more particles go into the vapor phase, then more particles will also condense out. So we have evaporation, and we have condensation occurring. Eventually, a constant pressure is developed as particles evaporate, then particles will also condense. And we have a state of equilibrium that will exist. So when evaporation equals condensation, we have equilibrium, which we're going to discuss more in a later topic. Boiling occurs when a liquid changes to a vapor in the body of the liquid. The normal boiling point is the boiling point of a substance at 1 atmosphere. So water, we say, boils at 100 degrees Celsius. But water only boils at 100 degrees Celsius when atmospheric pressure is equal to 1 atmosphere, or 101.3 kilopascals. If the pressure is different, water will boil at a different temperature. So we have Table H. Table H shows the temperature that a substance will boil at different pressures. So the curved lines shows the temperature at which a substance will boil based on the pressure. So if we are at the normal boiling point, 1 atmosphere, then propanone will boil at approximately 55 degrees Celsius. Water at the normal boiling point is a temperature of 100 degrees Celsius. So the dashed line represents the normal boiling point, which is 1 atmosphere of pressure. If we change the pressure, we change the boiling point. So if we make the pressure 50 kilopascals instead of 100, then water will boil at 82 degrees Celsius. So we're going to do this chart much more in class. This was just a quick introduction, but that is it for today. So we will see you in class. Have a great night.